All right, here we go, my friend. Maybe. Still be Soraya. Yes, Soraya. Yeah, have a seat. Let's dive in. We have 600 chat. Never start. Should win. All right. So you said you have some issues here graphing. So let's talk about this real fast. Two graphs. That's not very useful, but I don't actually. All right, the first one, it says, so for two graphs, on one graph, plot time on the y. Time on the y. That is different. It's not a huge deal. Those are two, so you can get this good. And then drops here. Correct? On the second graph, plot the reciprocal of time on the y. So we have 1 divided by time. So it's literally, you just take the number of 1 and divide it by the time values each time. On the y and drops on x. Okay, now. What's that? And drops in thiol sulfate. Okay, now I have no idea what this data looks like. The time versus drops, was it a linear relationship? Yes,
Ours wasn't, but we kind of messed up that.
was one of them later?
One of them was, and the other one was not really.
It's inconsistent, but it's very.
All right, how many of you got that the first graph is linear? Raise your hand.
I haven't done it yet.
All right, now do this and that. If I were you today, you're going to need TI calculator, so you might as well go grab one now. And we can talk about how to do this with a calculator. So go grab a TI and take it back to your station or your table, whatever desk is the way. If you have your own, you can use it as long as you know how to use it. Feel free to stand up and move anytime. All right, and then we'll teach you how to do something we're going to have to do, but we'll also help you with this lab. It's one of the reasons I made you do this lab. Because this lab is not super dependable. High school data is not very dependable.
In college, you have to get more dependable.
Sometimes they grade you on your accuracy. You also have much more controlled environments in college with more expensive tools. All right. You roasted me. That's great. Moving on.
Okay. Talking about how you Davidson, the college professor.
Oh, thinking about a college professor, and there's nothing more true I've ever told you in my life. They don't give a crap about you. Not even remotely close. And most of your college professors, they won't be involved with the lab. Whoops, whatever, we'll just do that. Okay, that one. They will have someone else do the labs for you. All right.
They can care less.
Yeah, the college professors usually mad that they have to teach. Yes.
Have you ever seen a video? There's this funny video of this guy. It's not real, but he goes up to a professor and there's a huge stack of assignments eventually. Yeah. Yeah. He's like, you don't know who I am. Yeah, do you know my name? He's like, no, I actually don't. He's like, great.
That's pretty accurate. I guess it'll be for time.
I saw you on stage, and I was feeling pretty old.
Wow.
when I saw you last, I was feeling pretty old.
All right. Let's go ahead and talk about how to do this with the calculator. This have what kind of slope did this line have? That looks like that. What does this one look like?
How do you do that?
You take the number 1 and divide it by time for each one of the times. And then plot that versus your drops. No one's done that graph yet? If you don't have a TI calculator, you will 100% need one for the rest of the hour and for the next couple of days. It's Cafe Rio, I believe. Just basically Cheeto.
Cafe Real was supposed to be that. Oh, yeah, you do it. I can tell you.
Then you leave it
Well,
alone.
kind of tastes the
I
same.
think they both taste the same. Yeah.
Cafe Real has a way better taste.
Cafe is way better.
Even though I haven't eaten at the Cafe Real.
Cafe Rio's better, but they both taste very much the same.
I don't really care. I will eat all of them. Fine.
Ricardo's or Cafe Real?
Depends on how fast or how big a herd of. Ricardo's is better to me.
Do we have to differentiate? Do we have to get our averages and like plot them, or can we just plot both?
You should do your averages.
Oh, okay. Oh, good.
Hey, what's the gland relation?
Under tongue gland.
It's actually
Is it
called.
the mandibular or the
Yeah,
salivary?
there's some mandibular. There's some other ones. There's like parotid, some mandibular, and there's one of the. There's after that one. It's some mandibular.
I think that's some mandibular.
Under the tongue gland.
You like that?
I love that.
I know human biology.
Why can't humans? Why don't doctors just name things the way they should be named? What the heck's a pharynx?
Because it's supposed to be relatable to other
It's not a little
languages.
animal with its skin.
Hence why,
Yeah, like a pharynx. That sounds like a phoenix. That sounds like farmington.
well, no, the
Well, I'm
reason
sure the scientist
is,
wasn't considering farming and anything.
Also,
the reason,
wasn't probably basing it off of English.
yeah, they're, all medical terms are based off of Greek and Latin roots.
Like jejunum. That
Yeah.
sounds like some like South American name.
Oh, how's your graph going? That's better.
Almost done.
I'm just confused. Because I don't know the blocks. I can't remember them. Was it 1, 2, 3, 4, 5, 6, 7, 8, or was it like 2, 3, 4, 5, 6, 7, 9, 10?
10, 9, 8, down at 3.
Yeah, what is happening?
So none of the ones are same.
Cooper, do you want to know why it's based off of roots?
Yes, I do.
It's because most
I got my
languages,
stuff.
most languages have Latin or Greek in them. So it makes it universal.
And English is just.
Okay.
I have linear one for the second one. No, English
Oh
is
boy,
weird.
we're in trouble.
Shouldn't it be exponential?
I don't know.
Should
Depends on-
your graphs
Maybe
be
I'm
opposite
using the wrong
of each other?
One should be up, one should be down.
Probably that's good.
Wait, this is the sole graph.
Because one,
Well,
as it gets
linear.
bigger, it gets bigger, but the other one's one over, so big.
Oh, like-
It's a linear decrease, right?
I don't know that term.
Remember on that test when this whole class didn't know indirectly or directly?
Yeah, I was kind of upset.
Except for like Nisha
I
and Caitlin. And
I got 50% on that part, because I guessed the same thing.
So Reese decided that she was gonna put the same answer for both, though she was right one at a time.
Yeah, because I have a 50% shot.
You want me to play or hit the game, my friend?
I think I did the same thing because I was like, I don't know.
It's actually a good strategy, though.
It is.
What do you do on the ACT?
Alright,
Yeah,
this
you have a
is weird.
25% chance, or you have a 25% chance to see this the single answer.
And then Reese did the 50.
Nope,
No.
that's not how it
It
works.
just, it decreases your likelihood of getting it wrong.
So number one.
Not necessarily. Yeah, but you have a 25% chance. Yeah, so it's right.
No, I'd say number one, 34.
Then your likelihood of getting
Why are you
it
telling me this?
right.
God, I'm not. Hey,
I guess
this
it's
is
different.
what? 4 months ago, John? You think I remember if I how I did on that test? I probably think that's fine.
Each one, two, I don't even know what that. Oh, and then that gives you. I'm gonna use. Oh.
Alright, we ready to use the calculator?
I already-
Because probably most of you are not perfect graph drawers. We'll see how well this works.
Oh, Ken. No,
Oh, that's statistics? I'm taking it right now. It sucks.
Oh, well, we have Grace who is taking statistics to
It's
draw
the
our
worst
graph.
class we don't, I've not done a thing, oh wait, I have like, two.
That's too more
Alright,
than
let's see
me.
if this will work.
We do more in calculus.
yeah, we do a lot.
We can zoom on phones.
This is good.
Wow.
And
That's cool.
Whoa. It's like, no troll anyway. Earthquake.
We got the earthquake coming.
It's so fun.
And you have to do
Super
the.
shit.
You need to get a robot, like connect your robot to it so it can walk around the class and show.
That would be,
You have to do the
that's the next level.
Yeah.
You know what I mean right now? I need a GoPro. That'd be
You like
perfect.
the.
Yeah.
Okay, here we go, my friends. Everybody have your data? How many say the first one's linear? Raise your hand.
Oh my.
How many say the second one's linear? Raise your hand.
It's a linear decrease.
Okay.
That's all I know. Well, maybe it's not fancy.
Let's,
It's a straight line that is going from big numbers to small numbers. How is that?
all right, we're gonna do something real fast here.
That's too much for my mind.
This is getting techno out of control. We can do this. I can do this.
You've got it.
Okay, Tom, a little. Hold your feeling.
Wait,
Okay. All right, here we go. You ready? Okay, take your calculators out. Now, I am doing this on a TI-84 plus CE backlit version. If your computer, or sorry, if your calculator is different than mine, it is your job to figure out how it works, not mine. Yeah, that is definitely not good for Kate. Okay, are we ready? Please pay attention. TI-86 is the most confusing calculator ever born in the history of calculators bornness. All right, ready? Okay, this is what I want you to do. It might take me a while to remember, but I'm pretty sure you go to stat and then hit enter. Everyone stick with me right now. Go to stat, which is right here, and then hit enter. Stat, enter.
Oh.
Yeah, it's edit. Stat, and then it's on edit. And then you hit enter. Now, this will open up a menu of lists. I don't know how well this will work. Are you with me?
Mhm.
Okay, I have data in my list. Did any of you have data in your list already?
Wait, are we supposed to
Okay.
put our average in?
Yeah. All right, so you're gonna go over to L1, and I'll go ahead and clear it out. I get cleared, I hit enter. Then, you put your data in for your time. Or whatever, your drops, it's up to you, as long as you keep track of what you got. So, someone give me the data for their time. Someone give me your data for your time.
29.
Okay,
Yeah.
never mind.
Never mind. You don't want to use those.
27.48,
Okay, next.
30.105. 30.5115.
You were that accurate on your times?
Yeah.
That's the average.
Okay,
That's,
next.
that's insanely.
34.6.
Are you sure these two were 30? Did I type that right so
Yeah.
far?
Yeah.
27, 30, 30, and 34.
Yeah.
Okay, not loving it, but we'll keep going. Next.
41.01.
Okay, next.
46.36.
Next.
0.225.
Next.
How are you so exact?
Their averages, she said.
Yeah, they're
Dang, who knew how good looking my hands are? Hi, world. Oh. Then I go my schedule tonight.
Was it ecclesiastical?
Yeah, well.
Ecclesiastical.
You got me another number, Reese?
yeah, it's 71.8.
That is.
Yeah, that's it.
Okay, I'm gonna go over to L2, I'm gonna clear it. Now, everybody, you should be putting in your info, not what I'm putting in. I'm gonna go and clear out every list. It's important you clear them all out, or things will get confusing. Doesn't feel like. All right, then L2, I'm gonna put my drops of thiosulfate, which were what?
It's just 1, 2, 3. Oh, wait,
Or
never
10
mind.
now.
Yeah, it's 10 now.
Then 3 is the last one. Okay, everybody look right here. We're gonna do this a lot today. Your lists must be the same length. That's why whenever you go to start a new one, delete and clear everything. Because if I had like a 1 under the 3, and then or even a 0, which wouldn't really matter, when I go to try and do what it does, I'll get an error and it won't work. Your lists need to be the same. Okay, now I'm gonna go up to L3. I'm gonna do a little bit of math. So the calculator does it instead of me. It wants me to graph 1 divided by time, right? So I'm going to take in L3, I make sure it's highlighted. I take 1. And I divide it by my L1. All right. So I come down and L1 is right here. It's the number 1. So I hit second and 1. And so now it's tricky, but L3 will now calculate the number 1 divided by L1. Wow. And I hit enter.
That is so cool.
You told me. Holy crap. It's like using a spreadsheet.
It is the
It
spreadsheet.
says data type error.
Oh,
That's like one presidency, by the way.
if you got an error, either your size is not the same or you have a 0 in your table somewhere.
Oh, I was clicking underneath instead of at the top.
Okay.
Wait, you did what and then what?
You did want to, so you have to clear it.
All right, now, everyone make sure you have 3 columns of data.
Which one am I supposed to do? L1, right?
The time data, was L1 the way we typed it. Okay, how do we feel so far?
Did you just have some fail?
What's that?
Did you just have some fail so far?
How we feeling? By the way,
How are you feeling?
were you,
Oh, I said who
you were
failed?
driving on President's Day, right? With,
Yeah.
for that,
Uh-huh.
I saw you in the morning, like 9:15 in your car.
9:15 exactly, Cooper?
Yeah, because.
Okay, give me thumbs up. We have 3 data tables in your list. 3 lists in your data table. Okay,
Cooper,
thumbs
why are
up
you
if
like
your
this?
attention is correct, not mistaken. Oh, okay. Oh, don't use a phone calculator.
I'm using this to get out.
How is that possible on a phone?
Okay. All right. Now, keep following along, because we're gonna do this over and over. You make it equal to, you make a function out of it. Now, it's already calculated, but I take 1. So 1. I make sure L3 is highlighted, so it's black. I take 1 divided by L1. So I get second and then the number 1, and that programs it to 1 divided by L1.
I like how they put L1 over 1. That was really hard to figure out.
TI-86 are very confusing. Okay, now I have the data I need. I want to graph it. So you got to stick with me. Are you ready? You're going to hit second and y equals 4. It's called stat plots. Now this is really tricky. Make sure they're all off except for the first one. I know 5 says on, but that's like, if I turn them all off, they're all off.
So 5 doesn't matter.
So yeah, all of yours should say off except for 1.
How do I turn it on?
Okay, so to turn it on, I'll go to plot 2 since it's off. I highlight it, which means it becomes like that black background. Then I hit enter, and then it's off. That's why off is highlighted. So I would just hit enter. It'll be on.
Oh.
I don't understand how some people
Oh,
are
and then
so
how do you
good
get
with
back to that and show why
calculators.
equals one?
They read the thing they want you to. Yes.
Oh, no.
All right, now, so I want to graph. So I need to, I'm going to select number 1. I'm going to hit enter. And then that now gives me my options. First off, it's on, which is what I want. But I want a graph of L1 versus L2. This one's at L4 right now. So I'm going to hit second and the number 2. And now I have L1 versus L2. Now let me hit enter for a minute and see if that's
Do we
right.
need to have a certain type of graph?
Hold on, I'll be there. I just have to check something. Because I think.
Wait, we're comparing L2 to L1?
That's what I'm checking right now. Because usually it is, but I think it's back. Oops. Yeah, we'll graph in a second. Hold on, this is janky. All right, so here we go. I'm gonna, all right, are you ready? So this tells me in the instructions on the sheet, I'm gonna make a graph where first off, I plot time on the y-axis. So that's list 1, right? That's what I put in for list 1. So see right here on the calculator, it says y list. You with me? I'm gonna change y list to L1. I want list 1,
And then
because
the,
I put my time data in.
Well, my drops on the first list, so.
Yeah. That's fine, whatever you need to keep track of however you do it. And then I'll make L2, because I had time in L1, I had drops in L2. Then I'm gonna hit enter.
Oh.
Why is it? So you just percent your out.
And then I'm gonna hit graph right here. Now, look. Look at this beautiful graph. You see it? There's nothing there, right?
Yeah.
All right. You need to hit zoom right here.
How do you pick that?
And then hit 9. You hit the button graph right here.
Is there data?
9 fits the window.
Fix the window. I feel like I could figure it out when you talk about that.
If I were you, I would not use that.
So
I
can
would
we
use
use
it
this
for-
for the second graph?
What? Yeah. Okay, so I have my graph. Now, it's a little hard to see there. Does that look linear?
No.
We'll
Yeah,
find
I
out.
don't know.
We're gonna take the one which is more linear. Okay, so now I go back to my stat plot and I'm gonna switch it. I'm gonna hit enter again. You can plot them both, except they're not in the same area, so your graphs get really weird. So I do one at a time. I would always do one at a time when we do this. All right, so now it wants my y to be, I'm just reading up there, the second graph is not the reciprocal on the y-axis, so that was my L3, right?
So should it be from L2?
And
to
that's
L3?
versus drops or time versus drops. So the way I have it, X is L2, Y is L3. I hit enter twice, so there, it knows they're there. And I hit graph. And once again, my graph is blank. So what do you do when your graph's blank? Zoom 9. And then to me,
That's not really-
remember how I didn't like one of Reese's values? I said, are you sure? Like, if you take out the one hiccup, this one's much more linear than the other one. Right?
Might be weird.
How's you weird?
So I put in the same value and I did my graph.
Okay. So those are stat plot. Just plot it both very same.
I need to know the plot.
First one, you can plot both, except for then scale. It's hard to say.
Yeah. So now if I want to plot
Remember how I said, you have 2 curves next to each other? Yeah. So that's what I'm.
it's very
Okay, now, hopefully you're using your data, not Reese's. But if you graph it, Reese's data looks pretty good. She has the one, I would say like outlier. It's not
yeah,
even
the
an outlier.
30s. They didn't seem right, but that's just
That
what we
didn't help
got.
at all.
It's also high school.
Yeah,
Yeah.
it's honestly really pretty good. She had the 2 that were 30, everything else kind of weird, but that's okay. If we sort of think, well, that probably shouldn't have been, then it's really pretty accurate.
I think I did mine backwards. Hold on. Mine
Possible.
looks linear.
you totally just figured it out. Yeah.
Caitlin Bennett.
Okay.
Okay.
Did you do the?
Now, hold your calculators up so I can see if you got a line plot.
I got the first one.
Yeah, it could look better, but at least, right now, all I care about you have on plot is that Reese's data or yours. Pretty similar. Really good.
How you guys had
No.
like
We had two values that were the wrong sign. One of them was like, this one was way taller than the
Like we have one outlier.
I did it actually.
Besides that.
other. That was.
Same way, there's another one.
we did pretty good except for that
Yeah,
one.
if you look at it, it hurts. So-
7. So this one.
Wait, did they make us like
Yeah.
So one major outlier, one side. Okay. How fun was that?
I actually figured it out.
Okay, probably better than your hand graph on a piece of paper was.
Yeah, yeah.
Alright. So this process tells us if we look, it's like hint, and then it tells you pretty much the answer. If the second graph has a slope of 0, the reaction is 0, so it's not that. That would be a flat line, completely flat. Next, if the second graph is a straight line with a non-zero slope, the reaction is first order with respect to thiosulfate. So we know from this data that it is first order. If I double the concentration, I would double the rate. If the second graph is parabolic, the reaction is second order with respect to thiosulfate. Write the law. You can put rate equals K. Now watch yourself do that on camera.
So why are we looking at the second graph with the reciprocal time and not the other one?
That's a good question. 'Cause what we're about to do, we're gonna look at both. Alright, so the rate law, rate equals K, and then thiosulfate, we would just put its concentration, and then we would put the exponent as a 1. And we're gonna call it good. Concentration is just the brackets.
What is parabolic? It's what we learned
Correct.
right before this.
If
It's
it's
what
not,
we learned right before this, right? With the exponents. That's all you're saying?
that's all I'm saying.
So
So
when you say that the second graph is.
let's try this a different way since this is already on and the camera's connected to it. So what we would say now, we would say that our rate equals K times the concentration of S2O3 minus, that's thiosulfate, right? Or is it 2, sorry, -2. And then the exponent is just a 1. It is first order, so that's my rate law. There's no I know it seems like H2, but if you go back to the instructions, it said it is acid catalyzed. So what we have the S2O3 minus 2 breaking down into SO3 plus S, if I remember right.
Oh, so like the.
But, yeah, it's a H plus right here. It's acid catalyzed.
Oh.
Yes.
What's the spectator ion of this thing?
Spectator ion, there'd be none. Well, sodium would have, because this really came as Na when I do. It came as Na2. So we'd have plus 2 Na plus over here, but yeah, they'd be gone.
Yeah, in the hydrochloric
Yeah,
acid.
I guess so. So we have H plus Cl minus, and we have Cl minus. Yeah. But when we're at rate law, we definitely, and it's good to remember spectator ions. So we don't have to worry about writing them out in the rate law, especially if it's catalyzed. So really, HCl wasn't part of the reaction, just let it happen. Let it happen. Okay, sort of okay? Now, I'm not gonna make you that, I'm gonna give you all credit for it. This kind of introduces us to what we're gonna call the integrated rate law. Now, the two people in calculus are stoked, They're like, we're gonna blow one away, we know how to integrate. We're not gonna integrate.
What?
We get the rate law from integration, but this is a chemistry class, we don't need to worry about it. It already is done for us,
I don't
so,
remember how to integrate.
well, neither do I, that's why I'm talking about it. Okay, I need to come back over here. My calculus teacher we let down as well. And he's still alive. Mr. Cummins.
Was that like a roast?
No, he was really old. Okay, my friends, there's some math on here you don't need to write down. I'll tell you when it matters. This lab, by the way, is just to kind of get you there, watching how concentration change. affected the rate, and then to get you familiar with how we're gonna do the calculator stuff. All right, so let's jump in here. What time are we out of here? One, okay, we got time. Okay, so integrated rate loss. So what we've done so far is we took and found the rate from initial concentrations. That's what we already did. That's where we said, all right, I doubled one and the rate doubled, so it's first order. Does that sound familiar? Okay, that is one way to determine the rate law for a reaction. What we're about to do is a second way to do it, and even though they get you the same thing, they're completely unrelated to each other. The next few data tables I show you have absolutely nothing to do with the first type of data tables that we did. So it's really tricky because kids try and make them match and they're completely different. So we've been finding the rate from initial concentrations. We're now going to find the rate from concentration versus time data. And we're going to use the exact same thing we just did. And it's pretty cool how it all works. Okay, so here we go. Don't write this down. But using calculus to integrate the rate law for a first order reaction process, it gives us this. It says negative KT is equal to ln AT A naught. Where? This is this lowercase o here, where A naught is the initial concentration, okay? And AT is the concentration at a specific time. This is a really cool math equation, because if I know K and how long and what I started with, I can find the concentration at any given time in the reaction. What we did before, it had nothing to do with time, right? It was just rate equals K times the two concentrations. This is pretty useful. All right, now, manipulating this equation, just using some algebra, all of this ends up with this type of order. So we have the ln of AT equals negative KT plus the ln of A naught. Now, it's, I don't know, if you're like me, and when I was a kid, I read this, and they're like, that's the form of a line. Like, no, I do not see that. But just trust me. This equation has the same formula as a line, where we have y, ln of AT would be y, equals mx, where m is my negative k, x is my time, plus my ln of A naught is my b.
Because it's your initial.
All right. So here's what's kind of cool. Since the equation is actually in the form of our point slope, something like that, slope, whatever, slope intercept form. Thank you. You're the best. Then if we get this data and we can plot it and it gives us a line, we're like, hey, line, maybe it's first order. And we can apply that. It's pretty nifty. So here we go. Therefore, if a reaction is first order, you can plot the ln of A versus time, and it will yield a straight line. And the slope of the line will be negative K. It's super, super slick. Yeah. So we a plot of ln of A versus time. We're going to put that data in. We're going to hit graph, and we're going to look. If we get a straight line, we know it's first order. If we don't, we know it's something else. Okay. Now, yada, 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 yada. You get all that stuff from that. Oh, okay. So here we go. Now, we're not going to do the math yet, but it just said we have this reaction. And I must say now, by the way, concentration, when we do this, and pressure are pretty much the same thing. Now, they're not by any means, but they're a measurement of how things changes over time. So the math will be the exact same. Because if it's something that's done in a solution and the concentration changes, that's a rate. If it's something done that's in a gas and the pressure of it changes over time, then that's a rate as well. So sometimes we use pressure, sometimes we'll use concentration, and it doesn't matter. We do the same math. Okay, so what we had was this data, And this was just how the pressure changed over time. You can plot that all day long. All right, but I want to know if it's first order. So I take the Ln of these pressures, and I put them versus time. This will make you all feel better. This time's on the x-axis. All right, so I have time versus Ln, and it ended up being a straight line. Since this was straight, it told us that the change of CH3NC goes to CH3CN is first. If the line looked like this, we'd say it's definitely not. Like that, definitely not. Look like that, we'd say it was a square root. Look like that, we'd say it's Tom Davis' signature. All right, but we want a straight line. Okay, so this is how we do it. Take those calculators out right there. So, back to calculator land. This is helpful. Okay, first thing, take your calculators and go to your stat plot, which is stat, and then edit, or stat and enter. Go to all your lists and clear them. So make sure L1 is highlighted and hit clear and hit enter. There may be a button to clear them all, but I don't know.
You can go to the top and just click clear.
Top.
Yeah.
How do we get higher?
Well, it just,
I'm sure there is. I'm just old. But I knew how to do this better than most of you already. Huh? I win.
That was a roast. That was a roast.
That was a roast.
I like roast.
Okay, so thank you. Now, if you're watching the video, I have a different data table on a different screen, but we'll just have to work through it. So we just put our time data in. So go ahead and type that data on the screen. So 0. Okay, I have my first data in, and it gives me my second data, so I type that in. Okay, then we're ready to go. Now, one more time, it's super important, the size of your list have to be the same size, or the computer explodes. It gives you a warning. It says this will explode in 32 seconds. All right, so then, that's the data. Now we're going to use the calculator to do the math. We need a plot of the Ln versus time, or sorry, concentration, right? So I now program L3 to be the Ln of L2. So on your calculator, you have a little button right here that says Ln. So push that. And then hit second and a 2 and hit enter. And now we have our data. They're in list 1 is time. List 2 is concentration. What? Okay, so I go up, I make sure L3 is selected. I need the Ln of L2, so I push Ln on my calculator right here. Oh, this is so hard to watch that. Ln right here. I push that, and now it's right there. But I need L2, so I hit second, and the number 2 will select it. You can close it, but you don't have to. Okay, you can ignore the top right corner. We'll move there, but probably not today. That's how you get a second order one. Right, well, I might as well put it. Okay, when you get to second order, look at the screen on the left for me. When you get to second order, it also has a thing that will be a straight line, and it's a 4th column of data. So while we're here, you might as well put it in. And you would have that be a calculated list, and it'd be 1 over L2. So we won't need it for this problem, we might as well practice. We have 1 divided by L2. Yeah, I have all the data. It is. Okay, now I have data, what am I gonna do with it next? I'm gonna graph it. So we have right here, when ln of p is plotted as a function of time, I want time on the x, I want ln on the y. So remember I have ln and L3. We ignore L2 this entire time. Like we programmed it, but we're never gonna plot it. Okay, so I go to my stat plot. I make sure they're all off except for one of them. And then I get to come down and I want X this time to be L1. So I hit second and 1. You with me? And then I want this one to be L3, which it already was. That was lucky. Right? Then I hit, I'm going to hit enter just in case. I probably didn't need to. Then I'm going to hit graph. And dang it, I screwed up, right? No, Zoom 9, it's your best friend. Zoom 9. Oh, boy. It's straight. That proves what? It proves that whatever reaction the milk was talking about, which was the concentration of water versus something else, this came from a reaction. It proves that it's first order.
And it was perfectly accurate.
It's very accurate. Now I gotta do something down here because I don't remember. Okay. Here we go. This part's really important too, and we'll go over it. I know I'm around this thing right now. This is cool and all, but there's more to this. It tells me it's first order, and it tells me something else. It tells me the value of K. Looking, K is the negative slope. Where is it? Right here. And the slope of the line will be negative K. So now we can't just look at it and know it. So we use the calculator again. Please watch the screen. You're going to hit stat again. Stat. Then this time you go to count. And then you go to 4. And it does a linear regression where AX plus B, that's what we want. That's the formula of a line. Then you have to check that it's L1 versus L3. Is yours L1 versus L3? Depending on how old your calculator is, if auto does it, but sometimes you have to change it yourself. All right, I went to stat. I hit 4. Well, long crap, I didn't want that to happen. Okay, hold on. Stat cal 4. Linear regression. Well, it's close. You see it almost clear my list. Okay, now there's nothing here. Look at the screen. I'm going to hit enter on all of them. Now, some years you don't have to do this. Down to calculate, I hit enter. And now it tells me these values. Which of your values the slope? A. So this says my slope is negative 0.85. My K, or my slope is negative K. So really, it's 0.85. I don't like future body language.
Yeah,
Was that good body language or like, oh man?
My calculator must have. All right.
Okay, this is what Nisha did. She slowly put it down and went like this.
like, you know, it's just bad when she goes like this. When she doesn't like notebook too, she goes.
Yeah, that well, that's how she,
Set it down.
it's smart. Instead of swearing in her head, she does what mature people do.
Yeah,
Yeah.
sure.
The rest of us are like, what the?
It's very civilized.
Cooper just takes off his shoes and tries to be one with the school. That's a
All right, so now we can see.
Guys, don't talk to me while I have my shoes off.
Hold
I
on.
need time to think.
I'm not.
This is so tricky. All right, here we go. So you learn some things from this. And I know this takes practice, but it'll be easy by the end of the month. You plot it. You get a straight line for the LN. That means, hey, winner, winner, chicken dinner, it's first order. The next thing you do is find the slope of this line using the calculator. The slope was negative 0.85. But K equals the negative slope. So K would be equal to 0.85. Now, I'll be ready to go. I have everything I need to be able to start calculating other values. Now, just real quick. If this was not if I did the first one and it was crooked, I would come down and I would check this one and just change L3 to L4. And then I would graph that. And then if the first one was curved, this one's usually straight. And then we'd say, hey, it must be second one. Then we're kind of in trouble.
Hey, do you want us to turn these loud?
No, I'm just gonna give them a credit for it.
So we can tell by the shape of the graph because it's exponential. Will we ever see a cubic graph?
No.
Some ever really the power or the third order?
It'll be third overall, but not third over